Welcome, dear my friends. Here is Zmotion Technology Tech Support. Today, let's learn about UDISK interface of Zmotion motion controller. Before that, please prepare needed materials and wire them according to this. Actually, if you don't have real controller, simulator can be used well. Attention, corresponding operations are done in our free IDE software, Zdevelop or RTSys, which can be downloaded from our website. And there is also video description. You can learn and operate together, whatever the controller model is. The UDISK interface is used same rule and supports same functions. It supports two main functions. Function 1, upgrade the program. Download ZAR program package into UDISK. Then use the command to load UDISK file. ZAR program will automatically run. In this way, system program can be updated directly by UDISK. Function 2, interact UDISK data with register data. It can read and write variables and arrays. Data in Flash, VR, table registers can be transferred into UDISK data mutually. You only note the file types. Different commands operate different file types. More details, please refer to RT Basic Manual. Next, how the UDISK achieves these functions. At first, enable it from the aspect of hardware. That is, insert your UDISK into controller's UDISK port and power on the controller. Then, controller UDISK LED will be on. Next, do some software configurations, which means using corresponding commands. Okay, these are UDISK commands. UState, you can know the state according to returned information. These three are for reading and writing variables and arrays. Obviously, read data from UDISK to variables or arrays. This, save data into UDISK. Then, these four are for data interaction with register. They are mainly for VR and table registers, because they are with same reading and writing formats. Same, read data from UDISK to table and VR. Write data into UDISK. You only need to use correct command. In a word, make sure that the UDISK is inserted. Then use UState command to judge variable definitions at first. Then see whether the UDISK is inserted or not. Next, write and read. Mentioned before, if you don't have real motion controller, you can use simulator. New build one UDISK folder under Zdevelop/RTSys path. Then, put needed UDISK files into this folder. Later, we will operate it. Let's see more commands and operations. File command, it is to load and search files of controller or UDISK. Please select function according to corresponding strings. There show commands with simple example. How to operate ZAR file by UDISK. Load ZAR, it is used to download UDISK file. The behind is specific ZAR package. For this, it downloads the main ZAR package file. Find first, find next, and find prev are for checking. And please assign where it is saved. The difference is first is to check ZAR package. Next is to check the next ZAR file. Prev is to check the former ZAR file. These two are for flash data. Copy controller flash data into UDISK. Copy UDISK data into flash. It can be seen it doesn't assign specific no, because flash no and SD file no are corresponding. That is, flash 0 is related to SD 0. Flash 1 is related to SD 1. More other string functions of file command. Use this command to load UDISK file in the way of byte. It can read several types of files. There are 4 parameters. File name, table starting position, how many table in total, and the offset, the byte offset of file reading. For example, it reads the file of text 00 and convert the reading result into ASCII code. Save them into 10 table, starting from table 200. No offset, because there is 0. If it is 1, it will read starting from the second character string. Here, the 00 text content is Zmotion. It can be known 7 string in total. Then, 7 are read. Each string is shown in decimal system. If the offset is 1, only 6 can be shown. But it still reads 7 data and copy the last data to achieve total length. Except load, you can use this command to delete assigned file. Let's see one routine. Use modbus_bit register to achieve UDISK execution by commands. There are 4 parts. Search ZR file and download. Save UDISK data. Read UDISK data. And delete UDISK data.
Open the routine file. Firstly, run the read and write test. Set auto run number as 0. Before, we need to judge UDISK state. Then use UWrite command to write data in UDISK SD0 file, and modify values of variable and run. Next, read out data in UDISK to cover formal data. Now, let's simulate this routine. Open the develop software in root directory, new build 1 UDISK folder. Then connect to simulator. Start debugging. Single-step debug, and watch data A. We could see, after you read executed, stored variables are read out. And A is the initial stored value, which means it succeeds in saving data in UDISK. Okay, next, let's see UDISK routine. Set auto run for HMI file. In basic file, it includes 2 subfunctions. One is initialization function, another is period function. In HMI system setting, fill in these 2 functions respectively. Then it can call automatically function in basic. And the initialization function only is executed once when power on. For period function, it can execute in cycle. Then set resolution, click OK. At first, put ZR file into UDISK. When there is no error according to debugging, click Project Make ZR file. Here, you can set password or bind controller ID. Browse and select the file. Click OK. Well done. Next, let's see the initialization function. This is to set password. This password is the same as set password when making ZR file. VR string register is used to save searched ZR file name, and it saves them to 20 addresses starting from 1200 in string form. This means define array, it must be global type. HMI text element calls this array, then show indication information in touchscreen. Open HMI view. Select window 100. Click this text file. It can be seen it uses defined array. Get information of array and show them. Relative functional key is to close this window. Define file command, it reads the result. And -1 means success, 0 means failure. Define ZR file number. Assign initial values for table array. Define variables and arrays that are to be read and written by UDISK, and assign values. Define flash reading and writing parameters. Switch to HMI interface again. Here, all windows are shown. These 3 are software windows. They are called when inputting data in touchscreen. Window 10 is initial background window. Window 100 is the pop-up window, showing indication information. Return to window 10. Element 1 shows it is saved into table 100. When table value is 0, it shows unconnected. When table value is 1, it shows connected. Element 27 shows Modbus bit 11. Action is set bit, which means reset Modbus bit 11 as 1 when pressing it, and reset it as 0 when loosening. Element 3, 6, 7, 8 are same as 27. They are only with different texts and different calling registers. These are used to control values of corresponding registers. Then, let's see period function. Use if to judge UDISK state. Table transfers the read result to HMI to show UDISK connection state. Following all use register to control program execution. Register values are controlled by HMI elements. When button is pressed, execute. If bit register 0 is pressed, file command finds the file in UDISK. Then save searched the file name into VR string starting position of address 1200 in string format. The result is transferred to result parameter. If fails to check, print information. Button is pressed, resume immediately. If command is only executed once. If bit register 10 is pressed and file is checked, at this time, file command will find the former 1ZR file. If no former file is checked, find the next 1ZR file and indicate the information the first file. Then transfer this information to run. Window 100 will pop up. If bit register 20 is pressed, file command will find the next 1ZR file. Same rule as bit 10. If bit register 30 is pressed, file command download the current found ZR file. The ZR file name is got from VR string 1200. If fails to download, find again and pop up window. Okay, next shows data interaction. Here takes table as the example and table and VRR with same method. If bit register 40 is pressed, stick right stores data of table 0 to 5 into SD10 file of UDISK. The last parameter is used to select store format. If bit register 41 is pressed, stick read reads data from SD10 file to table 0 starting position. The last parameter that shows format should be consistent with the right one. The next is register variables and arrays reading and writing. If bit register 50 is pressed, write data of variables and arrays into SD1 bin file. If bit register 51 is pressed, read data from SD1 bin file. If bit register 60 is pressed, write data to flash block 3. File command copies flash 3 data into SD3 bin file of UDISK, and their number are corresponding. If bit register 61 is pressed, copy SD1 bin file to flash 1. Then read flash block data. File command also can open UDISK data. Take the text file as the example. When bit register 11 is pressed, read text file of UDISK and save data into 10 addresses starting from table 200. And the last parameter means offset setting. Okay, now all UDISK knowledge is over. Hope you like it, and thank you for your watching. See you next time.